Hello. Okay, so second video. Today we'll be talking about data types in Rust. And to start off, I want to remind you of something I kind of hinted off in the previous video with constants, which is explicit versus implicit variable definition. Okay, so explicit variable definition will be something like let mut x, and I'm explicitly defining its type. So I'm going to call this a u8, and I'm going to say 0. Okay. Now, an implicit variable type, so I'm going to call this E for explicit, I'm going to call this I for implicit, would be without the explicit definition of the variable type. Okay, so this can be familiar to people who are coming from a JavaScript background because it might look like dynamic typing, but it's not. Rust is implicitly defining your type. Okay, now that we have that out of the way, let's get started. Rust has scalar types and compound types. For scalar types, it has things like integers, floats, bools, and characters. Integers can be either unsigned, which is what we saw right here with the example u8, meaning it's an unsigned integer with 8 bits, or we can have signed integers. An example of a signed integer will be an I8. Okay, so I for, well, signed. Anyway, an example of an integer, I don't think I have to tell you this, but int, I can then do u8 and say, suppose 255. Okay, this is an example of an integer. Surprise. Moving forward, we have floats. An example of float would be, I'm going to call this I'm going to make this an implicit definition. I'll tell you why in a second. And I'm going to say 2.0. Okay, so this is a float because it has a decimal point. And the reason I made this an implicit definition is to show you that here, Rust will implicitly define this variable float to be an F64, meaning it's a float with 64 bits. Okay, if you want to save some space in your computer and do some memory management, you could define this float as F32 rather than the F34 default. Okay. Now bools in Rust, they're defined not by spelling out the word bool, but by writing bool. Okay. And an example of a bool will be true. Okay, with a lowercase t. Something different in Rust than in other programming variables is that you can't just create b, okay, and it will have a default type of false. No, we don't have that. Okay, we have to specifically define that it's either true or false from the beginning. Now, one of Rust's most interesting types, in my opinion, is characters. Rather than default programming languages, Rust doesn't use ASCII. Rust uses the Unicode Scalar value, I believe it's called. And what it means is that rather than using 1 byte that ASCII uses, it uses 4 bytes, so 32 bits, meaning we have the possibility to represent many more characters than we normally would in ASCII. So we can use Chinese characters, but most importantly, we have emojis. So something that you can do in Rust is you can define an emoji. Okay, so if I go, let's now hop onto the terminal, I do print, I can then do this to print my emoji on the terminal. So we cargo run. Just a bunch of warnings like we usually do, because this variable is not going to be mutable, but ignore all those, and we see a little crab here. Okay, so yeah, in Rust you can define character emojis. Alright, moving forward to compound types. Actually, before we move forward to compound types, I want to tell you a curiosity. As I mentioned previously, we have unsigned and we have signed types, integer types in Rust. The way to define signed numbers is by taking the 2's complement. Okay, what does that mean? The way that we define the number 1 in binary with 4 bits is 0, 0, 0, 1. The way to define the number -1 in binary is by taking the 2's complement. The 2's complement means we reverse all the bits from this number. So by reverse I mean 1's become 0's and 0's become 1's, and we add 1 to it. So the reversal will be 1, 1, 0. Adding 1, we get 1, 1, 1, 1. Okay? So this is the 2's complement, which means this is how we represent +1. This is how we represent -1. Okay? Alright, now that we have that aside, let's talk about compound types. For compound types, we have two types, tuples and arrays. Let's start off with arrays. The way that you define an array in Rust is by doing let mut. You can give it whatever name. And if I want to do an implicit array definition, I can do 1, 2, 3. This means that Rust is implicitly defining the size and type of your array. Now, if I want to do an implicit array definition, I can then write, suppose I want to do a U8 type with size 3. This is how we define it. And let's just give it the exact same values. And this is an explicit array definition. All right. If you want to change values in an array, you simply do array 0. Let's make this 20. Okay. So if I come here and I print the array, important thing, the way that you print arrays is you can't use the default, this default delimiter. You have to do this to print the array. Okay, so print array 1. Don't forget the semicolon. If I come here and print array 1 again, we do cargo run. We'll see 1, 2, 3, and we'll see 20, 2, 3. Okay. Moving on to tuples. Tuples are very similar to arrays. The only difference is that we don't have to have one singular type for every single element in the array. Okay, so if I were to do this in an array and run it, you see we did get an error because expected integer and found a character. Okay, so this is not allowed in arrays, but in tuples, that's allowed. So if I were to define a let mut tup, check, make sure that you realize that it's parentheses and not square brackets, and I do 1, 2, and then C character, I can then print this tuple, and that's absolutely fine. Okay, so yeah, that's the main difference between tuples and arrays. They're not all the same type, and I encourage you to just try out a bunch of stuff with tuples, really. But I'll show you something that you can try. The way that you can change types in a tuple is, instead of the arrays where you do square bracket 0, in tuples you do dot and then the element that you were accessing. Let's call this, let's make this the little crab. Okay, so I come here and do cargo run, and could not compile, expected integer, found character. Okay, right here, what we're doing is we're changing from the type to a different type. So that's not allowed. See, so that's what I mean by trying things out. Just go all out, try a bunch of things, and figure out what gives an error and what doesn't. So if I were to do 2 and change it, we would not see it because we're not printing it. But if we were printing it, you'll see that we get the little crab. Okay. Another interesting thing that you can do with tuples is something called destructuring. So what I mean by that is you can define the tuple on the left-hand side of the assignment, and the tuple on the right-hand side, and this way you're separating each singular element from the tuple in an individual variable. Okay. If I were to print this, just print normal delimiter. I'm going to print x. Running this again, we see the x right here. So 1. All right. What else can we talk about? Let's create a new tuple. Let's call this tuple1. And inside of the tuple, let's put another tuple. See here, I'm just trying a bunch of things out, okay? Actually, let's not put another tuple. Let's put 2. And let's put 1, okay? Now, if I go here, and I print my tuple1, you'll see that I have a tuple inside of a tuple and another element 1. Now if I want to access this this little crab inside of the tuple, how do you do that? I can give you some time to think about it and try it out if you like. I'll give you the answer right now, so don't look if you haven't figured it out yet. But the way that you do it is, so you get the tuple that you're initially accessing, you access its first element, you have it within parentheses, and you access the element from the second tuple that you want to access, okay? So it'll be tuple1.0 parentheses dot 2. Printing this, we'll see that we get an error. Semicolon, oh, I forgot semicolon. Printing this, we'll see that we get the crab right there, okay? So that's tuples, this is arrays, and one last thing that I want to talk about is overflow, which is just a curiosity. So in Rust, if you have an unsigned integer you wait, the range of values that you have is whatever you can define with 8 bits. In this case, we'll have from 0 to the number 255. Okay, so what if I create, suppose a let mute unsigned type, explicit type you wait, and call it 255. So this is fine, it's within the boundaries. But what if I were to define a 256? If I run this on the console, I'll get an error. It'll tell me that it's off bounds. Now let's try that. Okay, we get error. Aborting due to previous error, overflow literals on by default. So it's denying this overflow literal. Okay, let's go back to 255. Now, I'm going to show you something interesting. Let's get unsigned. Let's do 255. Oh, sorry, let's do unsigned plus 1. So, what do you think will happen? Think about it. I'm going to run it right now. So this is your first panic. The Rust compiler is panicking at an attempt to add with overflow. It's not giving you an error. You see that it is finishing, always printing, but it's giving you this panic warning. Okay, so the code is panicking. However, if I were to do cargo, actually, before we do that, let's try and print. Okay, let's print this unsigned. Oops, I forgot the delimiter. Unsigned. Let's not forget the semicolon. Oh no. Let's run this. If I do the unsigned, it doesn't print. Okay, so it did give me the error at the end. Okay, so it's panicking, it's not printing because it doesn't have a value to print. However, if I were to do cargo, build, and build for release, let's see what happens. Finished. Absolutely fine. Okay. Let's try and open this, okay? So let's go to Finder, Code, Rust, my data types. Let's go to, sorry, Let's go to target, release, and let's run this. We got a 0. What this is showing us, it's that upon release, what Rust does is it wraps the numbers around. So from 255, it goes back to 0 so that we don't get the error. Okay? So yeah, that was the little curiosity that I wanted to talk about. And this is actually something that can occur in like actual major releases. There's this really well-known problem that happened in the game Civilization. You can read about it. It's on BBC. You can see that for the game Civilization, an unanticipated bug caused the peaceful character Gandhi to become hostile. When players chose a certain mode to play in, the value which defined Gandhi's aggressiveness rolled backwards past 0 to the maximum. Consequently, he would threaten players with nuclear weapons at every turn. Okay, so yeah, just a little piece of curiosity. I hope you enjoyed this video, and I hope to see you again in the next one.